I didn't find much in Algebra 2 where you needed to know it. So I don't talk about it much. Period to me is much more critical because frequency is the number of cycles that occur between 0 and 2 pi. So if you're talking about like a real life application, I mean 6.28 is 2 pi, so how many cycles are completed in 6.28 seconds? Like I don't know how important that is. So I don't do much with it to answer that question. So 5 seconds was our period. We're going to solve for b. So we multiply both sides by b. Divide by 5. Okay. So I'm just going to circle the kind of important things. That was just from the first sentence. The cycle consists of inhaling and exhaling. Velocity of airflow is positive when we inhale, so positive. Exhale is negative. Get it? It is measured in liters per second at time t equals 0. So here's the critical, some points. At time t equals 0, the velocity of airflow is 0 liters per second. At 1.25 seconds, the velocity is 0.6, so positive. At 3.75 seconds, the velocity is negative 0.6. So we're definitely oscillating above and below the x-axis, so I'm going to put the x-axis right down the middle. And we're not going to have a time less than 0, so I'm going to put the y-axis way over here. And it looks like I'm oscillating between positive 0.6 and negative 0.6. So can I count by 0.1s? 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. I can. So this is 0.6. This is negative 0.6. I'm going to label my y-axis what? Velocity of, I'll be even more specific, velocity of airflow. And what are the units? Liters per second. My x-axis is what? Time. And a full cycle takes 5 seconds, so we definitely want to make sure we get that. If we want to be conducive to the 0.25s and the 3.75, can we count by 0.25 or no? No, that would be 1 second, 2 seconds. So maybe every other can be 1 second. And then that way it won't be too difficult to find the 0.25s and the 0.75s. So at time 0, the velocity of airflow is 0. So we have 0, 0. At 1.25 seconds, so here's 1.5, so 1.25 is going to be there. Our velocity is positive 0.6. At 3.75, here's 3.5, so here's 3.75. We're at negative 0.6. Oh yeah, go ahead. You know where they are? Okay. So we're going up. Where's the 0 going to be? 2.5, right? Because we know that the cycle is ending at 5 seconds. So it's got to reach another 0 halfway in between the start and finish. So here's 2.5 seconds, which is also halfway between 1.25 and 3.75. And there's your 1 cycle. Now, truthfully, they gave us too much. I would just say, find a function that models airflow. I would not tell you this. Find a function that models airflow. You should be able to tell based on your drawing and your sketch that this is a sine curve. Okay? So the format when we're writing an equation that we plug into is the same one we had been working with. And we go through what is our amplitude, 0.6, and is our A value a positive 0.6 or a negative 0.6? Positive, okay. So that's 0.6 sine. Our B we've already come up with, so that's 2 pi over 5. Do we have a phase shift? No, so just keep that x minus 0. How about what's our midline? 0. So if you plug everything in, that's what we have, and you may or may not see brackets around that. And then we can kind of get rid of the zeros that don't make a difference, so we have this in this form. Any questions on that? Okay. Take a minute on your own, and I'm going to randomly collect a few of these afterwards to see how we scale, sketch, label our graph, and just sort of get as far as you can in 3 to 4 minutes, and then we'll take a peek at the tree. And here's what we have so far. We picked up on the minimum 10 hours, the maximum 14 hours. We've labeled our y-axis 1 through 14, number of hours of daylight, and our x-axis 1 through 12, which is the number of months. So we have a point at 6, which is the 6th month, June, 14 hours. And at 12, the 12th month, December, 10 hours. We know that the period is 12 months. Did they say something like that, or is that just what we know because we know how the year works? Yeah, we just kind of know how the year and the calendar works. So we have a period of 12 months, so 12 months equals 2 pi over b, and we solve b. B is 2 pi over 12, which does reduce to pi over 6. So that's really all we have until this equation here. So Taylor has the amplitude at 2, the b as 2 pi over 12. There is no phase shift apparently, plus the midline at 12. All of that without actually completing the picture. So first commentary, what should we be doing to complete the picture? We actually want to see a curve of some sort. So what other point should Taylor have plotted? Liam? 0, 10, because December is if 1 is January, then 0 is December again. So we have it really going from December to December. Okay, and we have, this is our minimum and this is our maximum. So she did also sketch a midline halfway through. The minimum at 10, the maximum at 14. That means there is a midline at 12. And then we cross the midline halfway between 0 and 6, which would be the 3rd month. So at the 3rd month, we're actually on the midline. And then again, we're going to cross it on the way back down halfway between 6 and 12, which would be at 9. So when you're sketching your curve, you want your at least 5 critical points. Well, this did tell us to write a sine. So now if this was open-ended, cosine would be the way to go. So we're going to actually do this both ways. We will do the cosine way. But at the moment, let's do it a sine curve because that's what they suggested. So given that this is a sine curve that we're supposed to be writing, at what point does our sine cycle begin? 3, correct. So here is where your sine curve actually begins. Do we follow? Okay. So is her A correct? Is the A value 2? If you just focus on the sine cycle, yes, it is going up first, so that's indicative of a positive sign. And it's got an amplitude of 2, so up to above the midline, and then it will later go to below the midline. So we like the 2. This is actually incorrect. Put a second set of parentheses around the x minus c. Depending on the textbook that you're reading, they kind of have a different way of showing that. I like to keep the b and the c completely separate. Yes, we may eventually distribute the b, but I like to keep the 4 variables all separate, meaning their own thing. So our b is pi over 6. And then x minus. Do we have a phase shift now? Yes. Okay, the sine curve got shifted. How many units to the right? 3. So that's x minus 3. And then our midline is 12. So not far off. It was a little confusing, I agree, because it should be a cosine curve, but yet they told us to write a sine curve, which is fine. You can always write a sine curve as a cosine or vice versa, and that's kind of partially what I'm illustrating here. So if you then distribute, we have pi over 6x minus 3 pi over 6, which will be pi over 2 once simplified. No, I'm fine with that. Unless it's multiple choice, obviously, and you're searching for a different version of it. Okay, so let's pretend it's open-ended, because if it's open-ended, almost anybody is going to say this is a cosine curve, forgetting that last section, because it's starting at either a maximum or a minimum. In this case, a minimum, but that makes it a cosine curve. So if we're writing a cosine curve, okay, what is our A value? -2. Okay, same absolute value of A in that it's 2, but it's a negative because we're starting at a minimum. And then you have your cosine. Your B is not changing, so that's still pi over 6. And then we have no phase shift if we do a cosine curve, which is why if you were choosing, you probably would choose cosine because there is no phase shift. And our D does not change. So your cosine version of this graph would just be cosine of pi over 6x plus 12. Now, a couple things to note from that. These two are the same graph. If I type both of those into my calculator, I'm only going to see one curve because they are coinciding graphs with each other. That's if I can find my calculator. Yeah. I must have taken it home over the break. I loved it. So if we type those in, they will coincide on a graph because they are the same thing. The absolute value of A, otherwise known as the amplitude, does not change. Okay? Whether or not one's a negative, one's a positive, obviously that can change. The B value is also not going to change, but whether or not there's a phase shift does, and the midline does not change. Okay? Regardless of whether you write sine or cosine. Midline does not change, amplitude does not change, and the B value does not change. Any questions on that? Okay? So if we go back, I want to go back to the first one. Oops. Actually, just kidding. Before I do that, I did want to review these other two. Here is this person's. So they maybe made the same mistake that Taylor did, in that they followed instruction. They did a sine curve, but they didn't have their 5 points really well labeled. So they've got the December minimum, the December minimum, and the June maximum, but make sure your zeros are well labeled. Really for this exact reason. We had to write a sine curve, so you want to know exactly what the phase shift was. And their sine graph is starting here. There's their sine curve. And so once you highlight that, you can see the phase shift of 3 units. But other than that, that's all good. Yes? And my other one, what do we think about this one? So it's 5, 4, 3, 2. What are our thoughts on this one? Yeah, their points aren't exactly right. They have June at 12 hours of daylight, where June was supposed to be 14. They have December at 12 hours of daylight, where December was supposed to be the minimum of 10. So their points are not right. So I don't know, maybe they were trying to make sure it looked like a sine curve rather than drawing the graph as instructed, as the details provide, and then kind of adjusting accordingly after. That's just a guess, but yeah, we got the points are just plotted. Okay, so let me pass these back to the respective owners. Take whichever one's yours and then pass along. And I do want to go back to the front. I want you to take a minute and pretend. Oh, not pretend. I want you to write another equation for the same curve, but I want you to write a cosine version. Mm-hmm. Yes, you may. Okay. Raise your hand if you're done. All right. Jack, what did you write? pi equals. Okay, so same amplitude. Jack used a shift right 1.25, so his cycle starts here, and we could kind of finish it out if we needed. But it is a positive cosine, so he kept the same amplitude, 0.6, kept it positive because this starts at a maximum. The period, or the b value is the same because the period is the same, so 2 pi over 5, there's his phase shift, and your midline is always the same. Did anybody do anything different? Stephen? Plus 3.75. Okay, so you did what here? I just don't get your phase shift left 3.75. So if I kept this going, and this is kind of what I started to do, if I kept going, I would reach my next minimum at negative 1.25, negative 0.6, right? Because here's your midline intersection. We go 1.25 units to the right, and we're at a maximum. So 1.25 units to the left, and we should be at a minimum. 1.25 more units to the left, we'll be back at a 0. So that would be negative 1.2.5 comma 0 would be that one. So I guess why would you go that far? Because I can't even get that far to really see if that's right. So negative 2.5, I'd be at a 0, negative 3.75, I'd actually be at a maximum. So if you did go with a shift negative 3.75, you would be at a maximum, you would be at the start of a cosine curve, but it would have been a positive. So that would have been okay. But I'm surprised you went, I think that was correct. I think this was the part that you... You went left. Instead of kind of going right and grabbing this curve, you went left and you thought you were grabbing this curve. And that's what I did. I wanted to do that. I didn't think anyone would do that. I'm glad you tried it. But I just wanted to show, instead of looking to the right and grabbing the positive cosine curve, I extended mine to the left and I grabbed the negative cosine curve, which is what you were trying to do. And this is the function equation for that. So you're starting at a minimum, so you use an amplitude and an A value that's negative, and then that was 1.25 units to the left, so there was my x plus 1.25. And so this cosine curve and Stephen's cosine curve and Jack's cosine curve are all the same curve. And there's an infinite number of ways we can do this. But most of the time we only shift a little to the right or shift a little to the left. And same thing, and obviously they're all the same as the original sine curve that we came up with, right? 99% of us, if we're just told write the equation of this, we're all going to write the same sine function. But truly there are an infinite number of possible answers depending on which way your mind wants to shift it to go to the cosine and how far. Usually we're not going to shift it more than a period. We're going to shift it the minimal distance, and I'll come up with pretty much the same answer. Does that make sense? The coinciding sine graphs, cosine graphs, the ability to write these in a bunch of different ways. Any questions? Your homework's there at the bottom. I would like you